Welcome to Vision Unlocked, the new AI eyes. In this episode, we explore breakthroughs from 105 computer vision papers published on September 28, 2025. From generative models to trustworthy AI systems, we decode the trends shaping the future of visual intelligence. Join us as we unveil the next chapter in AI-driven perception. Today's episode offers a guided tour through the latest in computer vision research. We will unpack major research themes and technical concepts, reveal key findings that are reshaping the field, spotlight 3 seminal papers, and preview future directions for artificial intelligence's evolving role in visual understanding. Computer vision is the discipline that enables machines to interpret and understand images and videos. It is foundational for technologies such as facial recognition, autonomous vehicles, and medical diagnostics. The field merges artificial intelligence, machine learning, and signal processing with the goal of building machines that can see and comprehend visual information similarly to humans. As a vital component for automating tasks involving visual data, computer vision is at the core of many advances in modern technology. The first research theme centers on generative models and image or video synthesis. Recent advances enable machines not only to analyze, but to create realistic images and videos. The GANji framework, for instance, benchmarks foundational generative models using Japanese kanji character data, facilitating comparison across approaches such as variational autoencoders, generative adversarial networks, and denoising diffusion models. Additionally, autoregressive models now predict spatiotemporal cubes instead of individual frames, leading to more coherent and realistic outputs. These developments in generative AI are unlocking new creative and analytical applications, pushing the boundaries of what machines can imagine and produce. The second research theme involves multimodal learning and vision-language fusion. Vision-language models are designed to bridge images and text, enabling deeper understanding and reasoning. For example, the Hunyuan Image 3.0 model sets new performance standards by integrating image and text comprehension. The Colab system automates the creation of datasets that link visual and linguistic data, while the PCRI framework evaluates the robustness of models when confronted with visual distractions. Crucially, the concept of grounding IDs has emerged, enhancing the alignment between modalities and improving cross-modal robustness, as demonstrated in the work by Hassani and colleagues. Efficiency, trustworthiness, and simulation form the third major theme. Advances such as auto-prune enable adaptive token pruning based on task complexity, increasing efficiency without significant loss of accuracy. Data-agnostic pruning methods have shown that they can rival more specialized approaches in certain circumstances. In terms of trustworthiness, models like FairVT-GAN incorporate fairness constraints directly during training, addressing demographic biases. In the realm of simulation, the VFSI framework enforces physical constraints in traffic modeling, improving safety and realism. Overall, simulation realism is emphasized as essential for the reliability of autonomous systems operating in complex environments. Medical imaging and scientific discovery represent the fourth research theme. Deep learning models are achieving notable results, such as classifying cancer in ultrasound scans, as demonstrated by Kim and collaborators. Quantum-inspired techniques are being applied to answer clinical questions from visual data, broadening the analytical scope of computer vision in healthcare. Privacy and continual learning are addressed through innovations like EWC-guided diffusion replay, which maintains model accuracy while protecting sensitive patient data. As these models advance, emphasis is placed on reliability, interpretability, and privacy, especially in high-stakes domains such as medicine. The latest research in computer vision has yielded 5 key insights. First, unified multimodal models now excel at both generation and understanding, as shown by Cao and colleagues. Second, the enforcement of explicit constraints has dramatically improved simulation safety, particularly in traffic modeling. Third, the introduction of grounding IDs has enhanced the robustness of multimodal models. Fourth, privacy-aware continual learning methods are advancing the capabilities of medical imaging. Fifth, video generation is shifting from traditional frame-by-frame prediction to spatiotemporal block approaches, resulting in higher quality and more coherent outputs. Several core methodologies underpin the breakthroughs seen in 2025. Diffusion models are used to generate images by progressively transforming noise into structured content. Transformers, which direct model attention, are widely used for both vision and language tasks. Mixture of experts architectures balance scale and efficiency by selectively activating model components based on input. Adaptive pruning and compression techniques are crucial for deploying models in real-world, resource-constrained environments. Additionally, self-supervised and continual learning frameworks enable models to adapt over time, maintaining relevance as new data becomes available. The first highlighted paper is the Huion Image 3.0 Technical Report, authored by Siu Cao and colleagues. This work introduces a unified model for vision and language tasks, comprising over 80 billion parameters. The model's mixture of experts architecture allows it to maintain both efficiency and scale, activating only a fraction of its parameters per inference, outperforming previous state-of-the-art benchmarks. Huion Image 3.0 is notable for open sourcing its code and weights, supporting community-driven research. It is recognized for its substantial impact and commitment to openness and reproducibility. The second key paper, VFSI, Validity for Spatial Intelligence by Kargi Chauhan and collaborators, addresses physical invalidity in traffic diffusion models. The authors enforce collision avoidance and kinematic constraints during inference rather than retraining models, resulting in a 67% reduction in collision rates. This approach sets a new standard for safety in simulation scenarios and is model agnostic, allowing for broad applicability. Selected for its practical impact, the VFSI framework demonstrates the importance of explicit constraint integration for reliable autonomous systems. The third seminal paper is Uncovering Grounding IDs by Hossein Hassani and co-authors. This study demonstrates how simple visual cues induce latent grounding IDs, which bind image and text representations for more effective cross-modal alignment. The presence of grounding IDs enhances both robustness and interpretability in vision language models, providing a concrete path toward reducing hallucinations. By bridging empirical progress with theoretical understanding, this work advances the field's ability to diagnose and design more reliable multimodal systems. Looking ahead, several directions are poised to shape the future of computer vision. Greater integration among vision, language, and interactive capabilities is anticipated. The use of explicit constraints and incorporation of domain knowledge are expected to enhance reliability, especially in safety-critical applications. Efficiency and privacy will remain central concerns to facilitate real-world adoption. Furthermore, interpretability and human-guided AI design are becoming increasingly important, ensuring that models are transparent and align with user intent. Continued openness and collaboration across the research community will further accelerate progress. This synthesis was created using a combination of advanced AI and human expertise. Summaries were generated with OpenAI's GPT 4.1 model for text analysis, while TTS synthesis was powered by OpenAI, and visuals were suggested through Google Image Generation. All content was reviewed by human experts to ensure accuracy, although some oversights may persist. All references are cited accordingly. This hybrid approach ensures that the presentation balances depth, accessibility, and scientific rigor. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.